Waiting,
There it is.
waiting. And we're live. Welcome back to another Corona Geek here where we talk all about mobile app development using Corona SDK. I'm your host, Charles McKeever, and today we're going to talk about putting turrets on your game. We've been creating a game. I don't know if you guys have been following along. If you haven't, you need to go back and watch some of the previous Hangouts, but we've been creating a game called Monsters Need Coins. It started out as sort of a gravity conversation / clone of they need to be fed 3, but I think it's beginning to take on its own life here. At least it
It's
feels
just
like it.
about ready to change into its own, morph into its own game.
Yeah, right. Exactly. All right, so joining us on the panel is Ed Marina from roaminggamer.com. We've also got Kevin from seaburngames.com. We've got Sergey from spiralcoachstudio.com and Stephen from isbalbastudios.com. All right. Did you guys watch the Apple announcement? Anybody?
I did.
I never watch those things. I just read them later.
Well, we're going to talk about that tomorrow night. We're going to talk all about Apple stuff, specifically tvOS, how iPad, new screen real estate on iPad Pro might mean to us, all those types of things like that. So if you're into some of the late night sort of hangouts that we've been having, join us Tuesday, tomorrow night at 6 p.m. Pacific. And there should be a link up on Google Plus if you want to check out actually, it's all over the place. We put it on Twitter and Facebook and all of those things. So go check it out. And come join us. We're going to talk about that kind of stuff. Did you guys see anything in particular that you liked?
Well, the iPad. Jason, you got him. Yeah, I don't want to start the whole conversation.
Right.
But the iPad, definitely. I've been waiting for that to be a real thing. So, yeah, that's.
Yeah.
Good.
I want the iPad.
You do.
Oh, I would definitely get one if I could afford it.
No, Sergey. Sergey said you want the iPad.
Yeah, I will try to save some money and buy it.
That's pretty telling because I think up to this point you've been sort of neutral on that, at least if nothing else, and haven't really been impressed by any of the recent stuff. I mean, I don't know if that's too far reaching to say any, but you haven't really shown much interest in their recent announcements. So the fact that you're interested in the iPad, I think that's a big deal.
Well, my old iPad is very old, and I need to replace it eventually. So I just had a choice: replace it with some Air or go big, and I decided to go big.
Well, I bought the Surface 3. I enjoy the form factor and being able to write directly on the screen. But I can tell you, if the iPad Pro, the Apple Pencil, and their smart keyboard live up to its promise, I'll definitely be selling the Surface 3. So if you're in the market for that, let me know.
So, Sergey, I want to ask you a question.
Yeah.
For me, the motivation to get that iPad is I feel like the iPad was always great, but it wasn't quite big enough to do serious work on. But now, with a screen that's almost twice as big, it feels like it's finally in the big leagues. It's ready for serious work.
Well, with this screen, you have to decide whether you want a tablet or MacBook Air or something, because the price is not that much different. And yeah, with this new big screen, with this new processor that can handle much more functionality, it's gonna be cool.
I don't know if you guys have used the iMovie on on a like an iPhone or a tablet here recently, but it works extremely well on the iPhone 6 or 6 Plus. So I'm thinking that one of the primary tasks that would drive me to buy a laptop would be something like movie editing or something like that, some sort of heavy hitter application that you would need. And I think that with the iPad Pro, we may be that's a tipping point where we may be starting to move towards, like Sergey said, people just buying that one device.
I hope actually, secretly for dual boot device like iOS and OS X, it would be magnificent. But for sure, Apple will not make any of this in the near future.
Yeah. Well, I think for app developers though, it's a nice. I think we're like I said, we're at tipping point. We're getting to that point where it's like now it's like, okay, I think serious desktop application developers would say, like companies would say, like I could see. Well, there's already some that are doing it. Adobe is, investing heavily in mobile and stuff like that. I can see.
What about Microsoft?
Yeah, I can see some of these companies that are just specifically desktop saying, "Hey, you know what? We're gonna port all this to mobile and focus on that for a while." So, and then eventually there'd be no reason to have a laptop, air quotes. So anyway, all right. Well, yeah, you're right. We know that's not. That's the one thing about talking about these things. It's hard not to talk about these things.
Yeah.
So it's good. I mean, I'm glad. I'm good to hear that Sergey is interested in this, and so we'll talk more about this tomorrow night. Did you guys see that there is a #1 app in the game category on the Apple App Store that is a Corona app? It's called Pop the Lock.
I saw it because you said it, and I wanna. They're the #1 free app.
Yeah.
Category even independent, not just.
Oh, is it category independent? I thought it was just in the games category, but it's category independent. All right.
Maybe it was earlier, but they're shooting up there.
It's pretty. I downloaded it. It's. I don't know if you guys have played it, but it's pretty straightforward. It doesn't even come with any instructions, which at the beginning is almost kind of like I don't know what I'm doing. But then once you kind of clue into like what your only options are, you're like, oh, I get it, right? And it's so you tap the screen, the little tick mark starts moving, and then there's like a little dot, and then when you tick mark gets over the dot, you hit the screen again, and you've unlocked the lock, and then of course it becomes more and more complicated as you go along. It's a cool game. You should go check it out. Pop the Lock. We're excited, that it's out there, and the developer has already. I mean, they have a lot of other games as well, but this one, I think the main point of this one is just how simple it is. It's incredibly simple.
Their page on iTunes, they indeed have a number of other simple-looking games, and they really have quite a few downloads. But I'm very skeptical if it's just some as they featured in the App Store.
Oh, you think it's like some sort of anomaly or something that's just
no?
Fluke?
It's either they are featured in the App Store or they have spent tons of money on the marketing.
Oh, okay. So you're curious as to how it's gotten to its current rank. Yeah. Well, here's their Tomb Breaker app, and it's a great little game as well. And it's but you can see, right? I mean, they got particle effects going on here. They've got lots of graphic design. They've got lots of little in-app kind of stuff, and obviously this Pop the Lock is sort of a big departure from that because it's pretty simple as far as the UI and the concept.
Somebody's phone call.
Yeah, that was me. I was plugging it back into the thing over here.
You said something important just a minute ago. I know we got other things to talk about today, but I wanted to raise it. I almost didn't, but it came up before the show, and indirectly. And you said almost no instructions. And we were talking about before the show how people complain and say, "Oh, I can't figure it out," or "This has got too many controls," or "This is too hard." How do you guys feel about I've almost gotten to the point. How do I frame this question? I've gotten to the point lately where I want to make a game, but I really don't want to put all the effort into going here. Do this, click this.
I think I'm sorry. I just want to jump right in here because I've actually thought about this Pop the Lock. How would you, without words, right? So that you don't have to make it internationally viable. Without words, how did you make this game more obvious as to what you're supposed to do? And the only thing I can think of is there's that dot that's on the lock, and I could see if you just made it like pulse just a little bit, right? That would sort of draw your attention to it, and then as soon as you tap the screen, the little tick mark's going to start moving, right? And then, maybe I'm because I already played it. Maybe I'm reaching, but it seems like that would make sense. Like you'd be drawn to, oh, okay, I'm supposed to do something else, right? Apart from that, you'd have to do some sort of visual that doesn't have words in it that shows you tapping in the screen to start it and tapping the screen to stop it. I don't know.
So you're saying you feel like that's still needed? Some kind of.
Well, I don't know. See, I would start with doing the pulse, right? Just to draw the attention to the dot, because at the beginning of the thing, I didn't realize that the dot was part of the interaction, I tapped it. The tick mark went to the dot, and then it stopped. And when it touched the dot, it was like, okay, you failed. And I'm like, well, what did I do there?
I
Right?
like when game waits for a few seconds, and if you're not doing anything, it just shows you an error or something what you have to do.
So you're saying like leave it as an option that only shows up if they need help.
Yeah.
Yeah. Yeah. I think you go either way, but it certainly needs a little something. And I think maybe it all depends on what your revenue model is too, right? I mean, with Flappy Birds, you want the bird to go crash and burn and at least once, and then for them to play after that. So
yeah, I mean, I only picked it up. I saw you because you tweeted it out before the Hangout today. So I played it for 3 minutes. I'm with you. Once I got it, you get it. But at the very beginning, it was sort of, and I like the simplicity of here's the thing, play with it, figure it out. I like that, but I think you're right that it could use a little something because there's sort of there's the line and there's the dot, and you can tell that you need to line these things up. But I think when I first played with it, I didn't know what my expectation was. Is the dot going to move? Is the line going to move? What's going to happen?
Yeah.
And I don't know that it needs to be before you've played any sort of demonstration, but I think it can be if you've had 2 or more unsuccessful interactions on your first go. Maybe then a little visual indicator pops up.
Yeah, I did play it several times before I was like, what? And it had been brought to my attention by Walter, and of course there's this email thread where people were like, well, how do you play? What do you do? And then of course I had the benefit of that conversation to see that you're supposed to do something and then line things up, and then it became clear, but it wasn't that way right from the beginning.
I'm just looking at the numbers here. They released 4 days ago, and the number 1 right now. That's quite impressive.
Yeah, right. So good for you guys. Good for I think it's simple machines. Congratulations, good job. Lots of success to you for that, for sure. All right. Well, speaking of games, let's talk about adding turrets to games. Now, this was your idea. Was this your idea, or your desire to kind of replicate something that was already in? They need to be fed.
It was not exactly my idea. How would I say it? It was a natural progression of following the cloning process.
I'm sorry, can I steal a couple more minutes before you start?
Sure.
Yeah, I'm sorry. I actually should have asked if anybody had any announcements.
Yeah, I want to make an announcement about my plugin works. So, if you can see my screen, the first thing that I've made is QR code scanner plugin that you can use. Next, I've made the Toast plugin notification that shows these little messages, very useful. And my next thing is Wiki Social Network plugin, which is I've sent it to Michael to make it available to everyone, but it's going on in the store, like all the preparation and verification stuff, so it's waiting there. I also made vibrator plugin. You can control vibration on your Android phone. Like Corona right now has only one vibrate method, and it's only a very simple one. Here you can tell for how long you want to vibrate, and you can specify a pattern. For example, you can vibrate Morse code or something like that. Very cool. Flashlight plugin to flashlight on/off. Very simple. And text-to-speech plugin. You submit one text string, select language, select pitch, speed of voice, volume, and it speaks for you. The downside of this plugin is that it takes some time to initiate text engine, and on good smartphones it doesn't take long, but it may take long on lower-end devices.
Is that pinging a web API to return that, or?
No, it's all native and it's all integrated into operation system.
Like that's cool. So it doesn't require a network connection to work.
No, it doesn't
That's
require
awesome.
anything. So yeah, and my next plugin that is also in development and waiting, one fix for Corona Enterprise code is NFC, and after that I will make a plugin for secure storage and keychain, so you can encrypt user passwords or maybe even encrypt some API keys that you use for Twitter or for other applications. So that sort of stuff.
So are these project-related, client-related things that you're doing, or you just kind of looked out there and said, hey, I think there's a need to do these types of plugins?
First 3 and NFC are my client-related, and vibrator, flashlight, text-to-speech are just something that I felt for.
Okay, that's what you wanted to do. Did you guys see the? Speaking of flashlight, did you guys see the new iPhone is going to the front of it will flash when you're taking a selfie, like a front-facing camera picture?
Yeah, it's really cool.
Yeah, I thought that was. I was like, well, that's a good idea, right? I mean, that's kind of cool. So I could see with the plug-in there, with the flashlight plug-in, maybe implementing it more than just a flashlight.
There's an app developer who pioneered that, who's going like, damn, now nobody's. Oh, pardon my French. Now nobody's
I'm
going.
actually I wonder what Google and other developers will do after all this 3D touch, like good pen and other stuff.
Yeah.
So once they came out to how to fight Apple, so it's interesting to watch.
Yeah. Well, they're certainly expanding. I'm curious to see how tvOS takes off and all those types of things. So, well, cool. Well, thanks for doing that. Thanks for sharing that with the community. I mean, I just got 1, 2, 3, 4, 5, 6 different plugins. And you said also, what was it? The other one. NFC
and secure storage.
And secure storage. So.
Yeah, I will make quite a few.
8 different plugins. Wow.
Yeah, I have plans for vector graphics. I have plans for Google Play services cross-platform. If it's not too difficult, I have plans for parse.com integration, like it's very requested. And I actually have a list. Let me check it quickly.
Wow. So are you
iBeacon?
Are you kind of hoping to cash in if and when there is a paid store option?
Yeah, that's what I'm looking for.
So I think that's a great strategy. Sort of get it out there early, and then when it's
it's a win-win situation. I get the money, Corona community gets the plugins.
Yeah, exactly. Yeah, no, not to say that you're just sort of thinking about yourself, but that this is a great opportunity all the way around.
So get them now while they're free, and then spread the word, everybody.
Yeah, absolutely. Well, and I was thinking because here's the other thing that I was thinking is that that's 8 different plugins here at the moment, and that requires support, right? And even if all you did was pay for support, that would be a great thing, right? Just to keep things going, things that are have value to you as a developer. So
yeah, if I make a plugin and it requires some extended functionality, somebody can say to me and say, hey, I can pay you, and you enrich functionality of this plugin. So that's totally gonna work.
Yeah, exactly.
Just a quick question on the plugin side. Is it all Lua based, or can you implement native?
They all are native Objective-C and Java.
Really?
Well, these are the ones that Sergey's making.
Yeah.
Right? But you can make
that I'm making
using Lua.
But you can make Lua plugins.
Yeah, and that's how I do mine.
3 Lua.
Okay, but you can use native as well. That's interesting. So if I want to make a plugin that uses the front and back camera, because at the moment that's not on Android, only on iPhone available in Corona, I could do that with a plugin with native elements, I suppose.
Yeah, you can.
Because everybody's screaming for that.
But you would not be able to pass it to texture. Like right now, you can have front-facing camera on iOS into like new rect and make it a camera feel. But camera feel would be, I think, quite difficult on Android. You can make your own view like that native display on top of everything if it suits you. That's definitely possible.
Well, let me send you an email later on today. I might have a little project for you to write.
Cool.
In your spare time.
Oh yes.
And a similar community thing, although it's not one of mine, I just want to draw attention. I'll find a link so you can put it in the show notes, Charles. But there was somebody created, and I haven't had a time to take it for test spin, so this isn't really an endorsement yet, but it's a cool idea. Somebody created a module that is like a in-app purchase simplification thing. So you can sort of, if you're building for multiple stores, use the exact same code base and target all of these things with the same API call to make purchases. And it just it was a really sort of a cool idea. So it's in the forums. I'll get you a link, Charles, so you can put it in there.
Badger.
That's right. It was IAP Badger or something like that.
Yeah.
And I want to say I had never heard of this developer before, but I sort of looked up what he had. And he has a great little game Corona made on a store called Laser Sword Chef 2099 with an exclamation point. And I love anything that has an exclamation point at the end. And it's a fun little casual game. So go download that. Go check out what he's doing because it seems like he's doing good stuff, and he's just throwing that out for the community to use. So good on him.
Yeah, that is cool. Yeah, what do you call that? Obfuscating or abstracting the that process would be great because as we know, all the different stores have their own rules, and it kind of stinks. I think that detracts. And this is one of the things that the computer industry as a whole has been struggling with for years, right? Is that standards. Trying to, in the early days, very early days, there was a lot of proprietary stuff and people trying to come up with their own thing and be the big dog and all that stuff like that. But they learned that if they had open standards and worked together, that there was a bigger market to be had. And I think that the app stores are kind of in that space right now where they're just beating the snot out of each other and hoping that one of them will come out on top. And the developers kind of get caught in the middle of all that. Okay, cool. Anybody else got any announcements? Anything else?
No, I'll make mine by the by as we go through.
Okay. All right. Well, let's do turrets. I'm really interested in this topic because to me this is one of those things that you always see in games and you go, I wonder how they did that. And to me that's just that moment where you're just like, if you can see that kind of the curtain pulled back on that, it will mean a lot of aha moments for other things as well.
All right. So first of all, I changed the name to add some exclamation points to make Jason happy. Jason's gonna like the game 3 times as much now because it's got 3 exclamation points. Smart Alec, I know. All right. So currently we got 6 levels now, and monsters need coins. I'm waving at the screen. I always do that, like you can see me. I kind of wish we had Google Hangouts had a camera and the ability to screencast.
Oh, that would be awesome.
But yeah, then our bandwidth would go to poop. So
we could definitely put a webcam up in your office and just
there we go. No,
watch Ed all the time.
You don't need that. Okay, so level 5 is I wanted to change this around a little bit. Level 5 contains your new element, so it's all about you. Invisible platform that you suggested and we made last week. And it's kind of a tricky level because it's got one little bit where you got to kind of like get your air control just right to pass through it. And you got 2, 4, 6, 7 coins you got to collect if you want to finish them all or get them all. Right now you don't have to collect all the coins to move on, but I think what we'll do is in a future week we'll add the logic that prevents you from moving on until you get all the coins. Level 6 introduces the turrets. Now I'm going to show you the turrets first, and then we're going to talk a little bit about the fundamentals, the concepts that you have to understand before you can even approach turrets. So we got this one turret here. Let me jump down here so this makes more sense. We got fixed turrets. So this is a fixed turret, and this is a fixed turret. So we got turrets that can point up, to the right, down, left, and then 4 more that can point up and to the right, down and to the right, down and to the left. So you can get these things pointing just the way you want them. Now they never change, and they always fire at the same rate. which you can modify for people who are following along. You can modify in common.lua, which is our settings file for basically everything in the game. There is also a rotating turret, auto-rotating turret, and it comes in a couple of flavors. It comes in a rotate right by 90 degrees and then fire, rotate left by 90 degrees and fire. So basically what you're seeing here is the 45-degree version. So we got a rotating to the right, rotating to the left, rotate by 90, rotate by 45, and every time it stops, it fires, as you can see. And then my favorite, let's go to it, if I can navigate here. The sensor missile. So we got a turret that, okay, that's not going to go well. Hard to demo these things.
Did you restart? Or did you die? You died.
I died, yeah.
Okay. I thought you restarted like real quick before you got hit.
No, I didn't. I died.
You died.
So this thing detects when you're in range. Basically, it detects currently the gap size, which is the distance from here to here. So when you're within 1.2 gaps, I think that was the setting I used in the code, you're close enough and it turns on, it detects that you're nearby, and it starts firing. And it fires missiles, not what I called lasers. The other things we saw there, you could think of as bullets. I call them lasers in the code, but whatever. It fires missiles, and these are interesting in that they steer, and they try to catch you. But then they run out of juice after 5 seconds. So as long as you can avoid them for 5 seconds, you're good. But if you're like me, then you're pretty much toast. So, although I'm doing great right now. Yeah. Oh no, not so much. Okay.
So the turret doesn't necessarily track your movements, but as the missile does.
I did not create that one because I wanted to leave that as an open thing that we might try to like put together. So there's two options there. We can make an auto-rotating turret or a turret that tries to aim at you and fires when it's aiming in your direction.
Okay.
Now the latter is harder, so I don't think we'd be able to get that done in today's episode, so we might try to do that in the future. But upgrading the current missile turret or rocket turret, what I'm calling this a rocket turret, we'll upgrading that to automatically also rotate, and just that way the turret has the possibility of being closer to you when it fires. We could do that today. Let's see, however, because I need to, before we can do any of this and look at the code, I have to introduce people to some basic concepts, which I know that you guys on the Hangout are probably pretty familiar with, but a lot of the people who would be doing this for the first time are probably completely not familiar with. So, in order to do that, just a moment.
Yeah, you definitely lay the groundwork for us.
All right, I'll do that. So, I complained on previous shows that I need some way to like draw on the screen and whatnot. So I made an app just for the show. And what I'm going to do is I'm going to release a binary for Android and iOS eventually for people who want to download this and use it. And it's very rudimentary. It's just a simple drawing program where you draw, and then it replaces the points with lines. You can change the thickness. You can change the color. You can change the background color. And it comes with 15 pages, so you can switch topics and write about topic A, write about topic B. It's got undo, so you can undo individual strokes that you've done per page. You can clear a page, and you can change the point size. So this just enough. Basically, I made this app. It's like 300 lines of code. Just enough for me to do this demo, and I'm not going to release the code yet. Probably not for a while. The reason is as I wrote this, I realized that there was something in here that I could use to make a product, and I don't want anybody jumping the gun on me. So what I will do is provide this to folks in a binary format for now on Android and eventually iOS, and we'll see where we go from there.
Okay, cool.
So let me clear these now that I've drawn on my pages.
I like it when tools get created in order to make other things.
I'm going to chime in and say, it's not going to have every bit of functionality you've got, but I actually have a module up on my site for finger painting, which is similar to what you're doing, not quite as full-featured. But if you need to throw a drawing canvas into an app, it's up there, and it does work.
Cool.
Yeah, I was kind of torn, right? Because this is the kind of thing where you want to like let people see it and whatever, but at the same time, I'm like, oh, darn it! I just had this idea, and I bet somebody else will. Following my rule of if you have the idea, somebody else does too. You can't let them have the work yet. So, anyways, back on topic. Let me get myself set up here. Let's first talk about screen coordinates and just the concepts behind vectors. So, if you are a student of geometry, I think. If you've had geometry, then you know about Cartesian coordinates and stuff like that. And when I draw this, oops, let's not do that. Let's do white instead. And if I draw this,
and you're using your finger, drawing on your iPad, and then you're sharing.
Well, I'm using a little pen, but yeah,
okay,
on my iPad, and then I'm sharing the screen with the Air Server, which is what do you use the other one? What's it called? For casting your iPad to the screen?
Yeah, it's here someplace. Yeah.
Anyway.
Reflector.
Reflector, thank you.
Reflector, yeah. So you could use Reflector or this. Anyways, so when I draw this, people are like, oh yeah, that's a Cartesian graph, whatever you want to call it. And they're all familiar with the concept that this is
That's a
plus...
D-pad.
Sir?
That's a D-pad. Nintendo D-pad.
No, it's not. But yes, Mr. Joke. So you're all familiar with this concept that in the Cartesian coordinate system, plus y goes up, minus y goes down, plus x is to the right, and minus x is to the left. However, and that 0, 0 is in the center, right here.
You got to do your best John Madden voice when you're doing this. It's like you got the telestrator up. I love it.
Okay. So, I don't think I could do that. That's why I'm laughing. Anyways, when you get into the graphics world, however, you got to adjust your viewpoint, and your viewpoint now comes in, and it looks more like this. Yes, the system continues off above and to the left, but most people, when they get into graphics, this is what you're presented with, where this right here is now the upper left is 0, 0, and y is going down is now plus. So whereas in Cartesian coordinates, going down was negative, going down is plus for graphics, and going to the right is still plus for x. So I only want to point this out because as we proceed, people will look at this, and if they're thinking in a Cartesian point of view, then when I start putting the y's in different signs, then they'll be confused. So remember that plus is going down. So the next thing that we need to understand, I kind of lost my train of thought there for just a minute, is, why don't we just do an example? So we want to create a turret, and we're going to have the good guy over here, and we are going to have the bad guy over here. And then we want to fire a bullet at this guy. But to do that, what we need to do is we need to do some math. We need to do some vector math. So the first thing we need to do is figure out how to point or to create a vector that will give us, will point in the direction of our bad guy. So this red arrow that I'm drawing here is the vector. Now, to get a vector, basically what you do is you take the position of, let's say, object A and object B, got a little more clear, and we'll say that the position of our guy over here is 10, 10, and our bad guy is 20, 10, so it's 10 more pixels to the right. What we'll do to get the red vector, this thing right here, is we'll say B, and this little line that I drew over that is something you might be familiar from school. When you put a line over it, what it means is it's a vector, B minus A, which comes out to 20 minus 10 and 10, whoops, minus 10. And these little brackets that I'm showing are just shorthand notation for a vector. So what we get is getting a little crowded here, but what we would get is, let me just draw it again real quick. And let's do this.
Need a scale feature.
I try to have a little bit of everything on here. Well, I did this a few times while I was testing it to see how the talk would go. So what we get for the red arrow, our red vector, is going to be minus 10, 0. That's what that ends up being. Given that, we can do a number of things. We can calculate what the angle is by doing a little bit of math. We can turn this into what is called a unit vector, and then scale it to get a velocity vector. So these are all the kinds of things that we need to do when we are doing turrets. So first of all, what is a unit vector? A unit vector is a vector whose length is 1. It's a special kind of vector that is always a length of 1, and what that allows us to do, having a unit vector, is to calculate things like, let's say we know that the vector points off to the right, and we want to move an object 20 pixels in the direction that the vector is pointing. Well, what we would do, or 20 units, forget about pixels, just 20 units. What we would do is we would make sure that our vector was a unit vector and simply multiply it by 20 and add it to the current position of the object we wanted to move. So I'm gonna do that on the screen here and show you what I mean. First of all, I'm going to show you what a unit vector of this one is here, right here. The unit vector equivalent of this one is -1, 0. Now I won't show you the math to convert a vector into a unit vector because I have a math library to do that of my own. But the point is if you look at this vector and you're at all familiar with vector mathematics, you'll easily see that the length of this vector right here is 1, which is very important. So now let's say that I have an object right here that I'm just going to make it up. It's at 1525. And I want to move it in the direction of our vector, -1, 0, 22 units. So the way I would do that is I would say 22 times -1, 0 plus 1525. And I hope that hopefully people can read this. I'm doing kind of a cruddy job of keeping these things on the screen. So what that comes out to be is the equivalent of -22, 0 plus 1525, which then comes out to the final -725. So again, what we wanted to do is we have an object here, right there, which is at this initial position. We have a vector here that points in some direction. In this case, it points to the right. -x is pointing to the right, and 0 means it's not pointing up or down. So it's a horizontal vector pointing directly to the right. Then using this to encode the direction that we want to move our object in, we want to move it by 22 units of these. And so what we do is we simply multiply this, I'm waving at the screen, multiply this by 22, add it to this, and then we get the end result that this moves over. Well, I drew a let's draw it exactly to the right. At the end of the day, that operation would move this guy over here by 22 units, whatever that might be, in the virtual space. So what does this have to do with turrets? When we have a turret, things we have to do when we have a turret. We have to figure out what direction we want to fire in, so we got a vector for the direction. Then when we have the projectile, and we want to move it at a certain velocity, we have to calculate another vector for the velocity. And that's pretty much it. So given that we've got the initial position of our projectile, we can turn the pointing vector here into a velocity vector and then use set linear velocity, and I can't fit it all on the screen there, set linear velocity to make that object move in the direction that we want at the velocity that we want, or in the magnitude that we want. Alright, so I can see that you guys hopefully this is clarifying things a little bit for people. Why don't we take a look at some of the code? So if you were watching last week, or if you've watched prior episodes, you will be familiar with level files. So our level files are merely a table containing 3 subtables, one for platforms, one for dangers, and one for other, where we use tokens to specify the virtual position of things. And I'm not going to go through it because we did this in a prior episode, but all of this gets sucked into game, a script in game Lua, and then another script in level loader, and it gets manipulated, massaged, examined, and converted into a table, a bigger table of subtables that can be used to build things. And in each case, when we build something, we call a function in one of the modules: round, square, laser turret, horizontal path, etc. And just find it here. I've got I just upgraded to Windows 10, so everything looks a little bit different. If you look under the scripts builders folder, you're going to find a whole bunch of scripts, and each one of these scripts is a module used to build one world object. For example, round is used to build these guys right here, whereas rocket turret is used to build this guy right here, the one that's firing the rocket that I've paused. So today we're going to talk about some of the turrets, and we're going to start off on the simplest one, which is the laser turret. So I say simplest, but actually this stuff, when you're first doing it and you're new to the math, it's kind of like, it's very complicated. So this is the point where I was going to say, Sergey made announcements about his plugins. I have decided to start propagating SSK content, some of it, as plugins. So I'm currently working on 3 plugins. One of them is the math library. I'm gonna extract the SSK math library, which we're using in this example, as a plugin. The collision calculator, which is my cheater for calculating the collision filters, is getting released as a plugin. And a library that I call the action library, which we may not have time to appreciate in its fullness here, but basically it takes the aiming that is going on here and the steering and the thrusting in the forward direction that makes it possible to make this missile. All of that taken down to 3 lines of code. So the action library is basically a super library, which isn't very long actually, but it's some fairly tight code that handles very fundamental action movements like aiming, thrusting, steering, stuff like that. Seeking targets, all kinds of stuff like that. It comes in the library, which will be a plugin released hopefully sometime in the next couple of weeks. Once I get my act together on the documentation. Now I don't know about you, Sergey, and you don't need to answer, but you can just nod your head. I think the hardest part isn't writing a code; it's writing the documentation. I don't know. Maybe Sergey could.
I have one thing to answer to that. You don't need to write documentation if you expose only a couple or one method of the library.
Unfortunately, I can't do that. That would be nice. So if you've been following along, I'm going to get back here to the file. The laser turrets are similar to all the other builder files. At the top, they require the common settings. They also now require utilities. One thing that I'm going to start doing here is I'm going to go back through this code. We've gotten to the point now where we've got 13 builders, and these builders are doing a lot of stuff that is similar. I'm not a big fan of having code that does the same thing in multiple places in my games. So wherever I find common actions, common code that can be easily moved, it will go into the utilities module, which then will allow me to do stuff like all of the junk that you see written here in several lines of code, or like this one, this really long one for drawing rocket trails, and use it over and over simply by calling a single function. So what I'm saying here is instead of including 100 lines of code to draw trails every time, for every time I do a rocket, I'll just have a module, builders, utilities, that is. I will require it here at the top, and then I'll call the functions in it that I need to draw the rocket trails. Okay, so another thing that you may not be familiar with, unless you looked at the player builder, is I'm doing a little localization. So as I just mentioned, I've got a math library that comes with SSK, and SSK will continue to contain it because I use SSK myself. But one thing I always do is I localize the math functions I'm going to use. So these are all 2D math functions. For example, this one scales vectors, this one subtracts vectors, normalizing a vector. Normalizing a vector, by the way, is how you take a regular vector of some length and convert it to a unit length vector, a vector of length 1. So I won't show you the math, like I said, because it's sort of complicated, and I'd probably stumble on the explanation. Another couple of functions I use all the time is converting a vector into an angle and converting an angle into a vector. Oh, and I forgot to mention that. This is important. Sergey and I think we're in different schools on this, but it doesn't really matter what school you are in on this, as long as when you do it in your games you're consistent. For me, this is 0 degrees. This is 90 degrees. This is 180. And this is 270. Now, some people prefer did I mess something up? Yeah, no, I didn't. So some people prefer this, but for me, it's just always been simpler to think of up in the game world as being 0.
Wrong.
Go ahead.
You got the second one wrong. It's 90 at the top.
Oh, some people do this then. Oh yeah, you're right. Via normal Cartesian. This always messes me up though. So this was.
Is that counterclockwise? Oh, okay. Zeros.
Is this 180 or is this 0? I can't remember that.
This is 0 to the right.
Yeah. That's Cartesian. It's flipped. That's another thing where people get really confused, is because when you're working on Cartesians, the rotation of these vectors, the angle changes, and the reason it does is because of the direction of the y, minus y versus plus y. So
In my
Long story
games, I
short,
always imagine 90 being at the top regardless of the y-axis.
yeah, it doesn't make sense to me personally to put 90 at the top because I don't think of a 90 as forward or up. I think of 0 as like up. I don't know. Because okay, so the reason I think this way, just as interesting discussion, is when I draw a picture of a guy smiling, he's up. He's facing up, right? So if I were to rotate him like this, then he'd be facing to the right. If I were to rotate him like this, he'd be facing to the left. And so for me, it's easier to think of up as 0 degrees instead of 90 because once I make it 90, and then if I rotate to the right, that's what? 180 degrees? It just starts to feel really weird to me.
For me, it's I imagine a plane, for example, or a car top down that rides from left to right, and that's very similar movement, very common movement in video games, and that's usually 0 degrees.
Well, that's an interesting point. I mean, I totally, I'm not, I understand what you're saying and where you're coming from.
Yeah, because in that case, the car would be up. In that, it would be pointing in the 90 degree direction, right? The
Right.
top of the front of it might be pointing towards 0, and then the top of the car would be pointing towards 90. What is that? Is that a pickle?
That's my poor man's airplane.
Oh, okay.
18 plus.
I'm not flying on
Long
air.
story short here, folks, those of you who are listening, we're in the ED coordinate system where this is 0 degrees, this is 180 degrees.
It's space.
Yeah, it's not a big deal. Just
Yeah, no, it's not.
some assumptions.
It's not. It's just that you have to realize as I speak that these are the things that I'm saying. This is the reference I'm using. 0 at the top, 90 at the right, 180 at the bottom, 270 off to the left. Rotating around in this direction to approach 360 in continuous increases, and rotating to the left to go minus.
Okay. Sounds good.
Seeing that, you're going to say something, Charles?
No, that sounds good.
Okay, so knowing that, all right, so we are back into the builder, and I'm running a short of time, so I'm going to really blaze through this, and we'll have to kind of come back to it later, because I want to show something to folks here.
Well, we're kind of laying the groundwork for the math and for the coordinate system and for all that kind of stuff like that. So yeah, we could come back next time to do, the basic turret itself.
Yeah, I'd kind of like to break down the details a little more maybe next time, and just give people the high level.
Mm-hmm.
So here in the laser turret, back to the laser turret, the way it works is they all have the same signature. They all have the same function, which is create. You pass it a layers, the data, which is the record that's describing the thing we're currently building, and a table to put pieces in. Again, I've said this on previous episode. The only thing that goes in pieces is anything that can be considered a gravity object, basically the platforms. So this is a piece that goes in the pieces thing. The turret here, the little red guy, and the rocket, those things do not. Okay, we have from previous episodes, I've talked about this. This example comes with what I call nice graphics, and you can call it ugly graphics, whatever you want. I'm maintaining that here. So for our turret in this case is built up of a circle, which is going to be a platform. You can actually jump on the turret platform, and you can touch the barrel. That doesn't matter, as long as you don't get shot. So I'm just going to use the same image that we've used previously, these circles. You'll notice, however, that I made the circles a little bit smaller than the regular platform. And the reason I did that was because I wanted to draw these turrets with the edge kind of sticking out. It just looked better. I could have made it the same size, but it didn't look good to me. So this is just like the round piece. I've got the pretty one that uses the Kenny art, and then I've got a circle if I were doing the ugly version, or I had the nice graphics mode turned off. Let's ignore this bit. This is just the label that tells us the distance, and we got it in debug mode. That's basically what I did here was I copied the round builder, and then I started to add code to it. So this stuff is all the same code as was previously in the round. So we've talked about it before. It hasn't changed, with the exception that I made a new variable called turret size, and that's a little bit smaller than the normal platform size. Here's where it gets interesting. So the first thing we do to make this different is I create another piece of artwork using an image from the Kenny collection of free art that I have and I'm using to build this game. And I think it was one of the pieces that was used to design like aircraft or spaceships, and I copied it and renamed it to turret because it looked like a turret to me, and that's what I'm doing. It's not a spaceship anymore. It's a turret. So we create this little bit of art, which is this guy right here in red. And initially it is pointing up, which for me is 0 degrees. So that's the default position. I place it at the same position that I placed the piece that we just created, the platform. And then I store a reference to the turret in our platform piece. And the reason I did that was because I wanted to have it if I needed it for future scripts. So if I needed the platform itself to do something with its turret, I could do that, and it would have a reference to the turret that it owned, quote unquote owned, and it would just make the coding easier for me. So if you recall what I said earlier, the laser turrets, let's start the game again here and go to level 6. The turrets come in these options where they can point up, they can point to the right, down, and to the left, or they can point at 45-degree angles, basically the same, upper right, lower left, upper left. All of that code is done here. So if you recall, our level markers look like this. They have a letter, an underbar, and then a number. Now the number is the subtype for that one. So the subtypes for the laser turrets basically tell me what direction should it be facing. If the subtype is 1, like, let's find the laser turret, J. So we've got J3 there. So J3 would be here, and that means rotate the turret to 180 degrees, which would mean that it is pointing downward. That's this one right here. So if we wanted this one to point to the left, we would make that a J4. Save it, reload it. I got to run down there to find it. And now it's pointing to the left. Of course, that's not what I want because it doesn't make this level very difficult to play if it's pointing to the left. But the point is using this format, we have a very easy way to lay out our turrets and choose an angle. Now, I just want to say that at this point, this system that I have encouraged us to use is starting to break down. It's hard for me at this point to remember what the different labels mean, like which turret or which laser thing or whatever it is, and I'm running out of letters. So this may very well go through a future change, and I want to push this out there now before we go on. Think about it in a future show, or if you're watching and you want to write back in the forums, or when Charles posts this in the blog. If you guys think we should do a editor, then let us know. Let me know, because we could definitely do an editor. I just avoided it because I wasn't sure how far we were going to take this game. But I think that at this point, having so many different things, if we had an editor, that would really open up the level design, and I think it would also be a useful topic for people to understand how easy it is to write editors for your games in Corona.
I think it's a great idea.
So we've done an editor before, and it's really the same principle. It's quite simple.
Yeah, but I think we talked about this last time where we said this game has kind of taken on a life of its own, and it's got a good code base, and so it would be great just to continue with that example. That way people can kind of tie it all together.
Yeah, I mean, I think that would be cool. And it'd be enough for people to really take that and do something with it.
Yeah, yeah.
So what have we got so far? So far we've drawn the base, the little circle, and we've drawn the turret, and we've rotated it. Now what we need to do is the bit where we start firing, and we create a projectile, and we do something with that. So if we get down here to line 87, again in laser turret, what I decided was the easiest way to do this was simply to use a timer, and every so many seconds to fire a projectile for the laser turret, the non-rotating one. So the way I did that was I used a little trick that I know that I would like other people out there to know. If you're familiar with Corona at this point, and I think you probably are, then you've probably seen a timer perform with delay function call where you put in like 1,000 milliseconds and function and do it, something. You do some code in here and that's it. What this is saying is wait 1 second and then call this closure. Closures are special functions. This dynamic function created at the time it was run, and inside that function do whatever we did. So call do it, turret rotation equals 25. I'm just making stuff up as I go. Okay, just make this function as long as you want. And this is basically how you would wait 1 second to do a number of things, whatever those things may be. Now, the trick that I want you to know about is this is true of a lot of different features in Corona. But for example, if we wanted to, we could say turret timer self. I'm sorry, function self. This code right here. And then keep the old code so you can see it side by side. Here's the code that I just wrote where we called function do it and we set the rotation of turret to 25 and we waited 1 second to do it. Another way to write that same code is to write a function like this, store it in a variable called timer on turret. So basically turret now has a variable called timer that points to this function. And now we can say timer perform with delay 1000 turret. Pass in a reference to turret, and Corona is smart like this. It says, all right, that's not a function. So I'm going to assume that you just passed in a table or object, display object, and I'm also going to assume that there's a field on there called timer, which is the function that you want me to execute. So now the reason why I like this instead of doing this is it's more self-contained. It's a little safer. Now, I don't know. In this case, it's not a big deal, but for like touches and collision events and all of that, anything where there is an event that has a name, you can create a field on an object or a table that has the name of that event and use it as a reference to a function, just like you would. It would have, the function itself would have the same signature as that collision, that listener that you would be writing. And it's a more compact, tighter way to do this coding, and it's a little bit safer in terms of like making sure it doesn't get called after the object has been destroyed and stuff like that. So let me get rid of all this code. I'm going to take us a little bit over our time because I just want to finish this discussion. So again, what we're doing is we've rotated our turret, and I want the turret to fire every so often. And I decided to do a timer, so I created a function, stored it in the reference timer, and the very first thing I do is, even though this is a very safe way to do things, I kind of like just to be sure. So the first thing, whenever I have like an enter frame or a timer and I got to manipulate an object, I verify that that object hasn't been removed in the interim. Because what can happen is if you defer an action using timer 1 second, and then 500 milliseconds later you delete that object, and then another 500 milliseconds the timer wakes up and you try to do something with it, you could crash your game. Why? Because you may try to call a function on the reference that is not there anymore. It's been removed. So a very simple way to determine if a display object is still valid has not been destroyed, not removed, is check to see one of two different things. The most common one is just check for the existence of the remove self function. So if you say self, which is the object, the reference that gets passed in here, remove self, if that is equal to nil, what that is saying is there's no longer a function called remove self. In other words, the object kind of still exists. There's a table out there, but it has been destroyed. It's been removed from the Corona display queue. It's no longer a valid display object. So if at this point you tried to say like self.x equals self.x plus 10, that would crash on line 94 because you're trying to reference self.x in a and then do some addition with it, which is completely illegal. That's like saying self.x equals nil plus 10, which is an illegal statement which would crash your game. So again, this little tiny bit of code, which I usually just compact into a single line like this, simply says, hey, if you came in here and the object that I'm about to manipulate has been destroyed, just quit, exit, get out of here, don't do anything. Now there's a trick here. There's a little bug. I consider it a bug, whatever. If you've got a body on your display object and you come into a timer or enter frame, what can sometimes happen is the object has been removed, but the body still exists for one additional frame, which means that this first test here would pass. But if I said this, it would fail. So again, what's happened here is in the time since I set the timer, or if it was an enter frame, and since I set it and since we got to this point, the object got deleted, removed, destroyed. Corona thinks it's no longer a valid display object. But for whatever reason, for one frame, it can sometimes happen, the body is still around. So what you want to do is you want to check for the existence of set linear velocity, because this will definitely be set to nil once you've done a destroy or delete. So there'll be no way you can get in here and accidentally try to do some physics action on a body that was just deleted. So again, this is safety code. It's a little trick that I use to keep my code from crashing when I'm not 100% sure about the sequence. People told me that I'm doing things wrong, and yes, okay, right. The best way to do this, the safest way, is to cancel all timers, to cancel all enter frame listeners. But I'm kind of a lazy programmer in that I like to catch things just in time sometimes. And so this is my way of catching it just in time. It's the more complicated your display objects get, the more things you've got to track in your cleanup code, and it seems to me it always opens you up to that 99% of the time it works, and then 1% of the time after you released it, it didn't work, and if you'd just been safe, it would have been fine. So, using our timer, what we're going to do is we're going to create a display object, give it some color, give it a size, store it in the position of our turret. Then we're going to add a body, and we're going to use another filter, which I have set up in Common. If you remember in Common, I have set up the collision calculator so that I can simply set filters by saying give me or get the collision filter that goes with the name bullet. So I decided to use bullet as the object type or object name for lasers and rockets, so they all use the same one. And the rules for bullet are that bullets can hit platforms and bullets can hit the player, but everything else they pass through. I also set laser is sensor, so what I want is I don't want any collision response. I don't want it to bounce off of things or stop when it hits something. I just want it to keep going. But I still want to detect that there was a collision. So the is sensor flag is saying yes, continue to detect the collision and throw the collision event, but don't respond. Don't bounce, don't stop, don't do any of those things when you hit something. Pretend like you can just keep moving. And then, because it's moving, generally anything that's moving and can be moving quickly, I use the isBullet flag, which is, it's a tip to the physics engine, which says, keep an eye on this thing and process it a little bit more because this thing is moving and it has a higher likelihood of hitting something. So you don't want to let it do what's called tunneling. Tunneling is when an object is moving, it has a physics body, and it's supposed to hit some other object, and instead it passes through. Tunneling. So to avoid tunneling, one way you can do this is simply set the flag isBullet to true, and you've decreased the likelihood that a fast-moving object will simply pass through another body without reacting or triggering a collision. Okay. I keep my eye on Sergey down here because every once in a while he wants to comment. He looks like he was going to comment. And I didn't want to go into the setting more physics parameters and stuff because there's other ways to deal with that. But first order attack is simply set it to isBullet and see if that fixes your problem if you're getting tunneling in your game. Okay, so we've got a new display object. We've got a new body. All we got to do is make it move. So how do we make it move? We determine the direction that the turret is pointing, which is the rotation of the turret, and then we use my function, angle2vector, and we say, take the rotation and return to us a vector, a table, containing the x and y vector that represents that rotation. So I wish I had a good way to show you this, but I do not. I can't go into this too much right now because it's rather complicated, the signature here, but this function, all of my 2D math functions are very malleable in the sense that they can take a large number of different signatures. You can call them different ways to get a result. So what this is doing here is passing back like a table that looks like this. That would be, it would get a whole table, oops, it looks like this. The reason it's doing that is because I put true here. If this was not there, then what it would pass back is two values, where dx would have a value equivalent to whatever was passed back here, and dy would have this. So again, what I wanted to do is pass back a table, so I say true. Like I said, I'm going to release this as a plugin, and at the time when you can get the plugin, this will all be documented. But the reason I did this is because I wanted it to be very flexible, because then I could do things like my vector sub, where I could take object 1, object 2, and that would subtract the object 2's position from object 1, or I could do type, save my life, sorry. I could see with the same function, I could pass it 4 arguments. The beauty of this is when you use it, this one knows, oh, you passed me 2 objects, so then I will return a single value. That value will look like this. However, in this case, you passed it 4 arguments, which means you were kind of like splitting things up by yourself. So then it knows return 2 values, which are still equivalent to the vector. It's just the function itself kind of senses what you want to do. Now, most of the time, I use it like this, but occasionally I got to break out the values and do it like this, where I pass in individual x and y values. But let's say, and I know this is kind of off topic, let's say I wanted to use it like this, but I wanted to get a vector back. And I would just put a true at the end. And true is basically saying, whatever the normal return was supposed to be, do the opposite. So I know this is completely sidetracking. I kind of wish I had the documentation available for folks so they could look at it right after this and go, oh, that's what that means.
But the big point here is it's going to do all those calculations for you, and you don't have to worry about it, right?
It does all these calculations for you, and the library is extremely flexible in that you can use it a number of different ways and get your results out, and it's quite fast. So, all right, so what we've done here is we've calculated a vector that points in the direction of our rotation. Now what we're going to do is we're going to take that vector, we're going to scale it. We're going to turn it into from a regular vector into a velocity vector. And a velocity vector embodies two things: a pointing direction, i.e. the direction that the thing is supposed to move in, and how quickly it is supposed to move there, which is called the magnitude of velocity. So I have a value in common called laser speed, which I think was like 350. And what I'm saying is take this vector, which we converted from an angle, and make it equivalent to give it a magnitude of 350. And then finally, given this just 3 steps, we can use the set linear velocity function, which comes with the physics engine that comes with Corona, and we can set the velocity of our object to be those two values, vector x and vector y. So long discussion, but the essence of it is take an angle, convert it to a vector, scale that vector by the magnitude that you want the velocity to have, and then set the linear velocity to be vector x, vector y, and you are done. At that point, the bullet is moving, the laser, the whatever. Okay, so there's more to this, and I think it's too much to go into, but we have a collision function here, and it's going to detect when it hits a platform or the player, and if it hits the player, it restarts. It dispatches the reload level event, which from many episodes prior I discussed, and basically what that does is says, oh, you died, redraw the level, start over. However, if it hits something that is not the player, it simply destroys the bullet, laser, whatever it is you want to call it. Now you will notice that I have this variable here called laser ignore platform. And the reason is because if you think about it, when these things fire, what's really going on? What's going on is it creates this little red object right here. Now you can't see it because I pushed it back so that it's underneath everything. But if I were to not do that, take this piece of code out right here, go back in, okay, I'm going to try to catch it. There. Okay, so right here, this turret just created this laser, and as you saw, momentarily it was right in the center. Now this is a platform, so our collision has been set up to do what? Lasers are allowed to hit the platform, detect a collision with the platform, and the player. And the reason I did that was because I wanted these things to destroy themselves as soon as they hit a platform somewhere else. But I don't want them to destroy themselves as soon as I create them. Right? I didn't want to have to do the extra math, say push that laser out here before it starts moving, or I just wanted to create it here and make it move, but I didn't want it to destroy automatically right away. So what I did was I cheated. I set a flag on the laser called ignore platforms, and I set it to true. And then in here it says else if ignore platforms is not true. So this is the same as if I said self. Right? Yeah, that's the equivalent of, I should have said that, make it a little more clear. So is it the player? No. Okay, well, I hit something. Oh, well, is the flag on this object set to ignore platforms? If it's false, if it's false, okay, I'm not ignoring platforms anymore, delete it. So I didn't hit the player, but I hit something, and I'm no longer ignoring platforms. So delete it. But initially, when this thing starts and it's moving, the collision event fires. But this is set to true, so this piece of code doesn't execute. Instead, what I do here is I cheat it, like I said, and I wait half a second using a perform with delay. I wait 500 milliseconds, and then I call this closure. And in the closure, I say ignore platforms, false. So what happens? Come on, this is one thing I don't like about Windows 10. It's hard to find the drag bar. The thing gets created, it moves, and a half second later, somewhere around here, that flag gets flipped. And at that point, now anything that it hits that is not the player, boom, it's going to get deleted. The response, the activity, whatever it is, it behaves the way I want it to.
Now you said that you didn't want to do the math to start the missile at the end of the turret.
Yes,
so how does that compare to what you're doing there? I mean, in terms of complexity.
It's just as easy for me to do either, but it was easier for me to explain a cheat than it was to explain additional vector math in a big long piece of code. It would actually be longer because I would have to do something like this. Which direction is the vector pointing? Move it by that much. And the thing is actually after all that, I decided that if I moved the laser and I created it right here, well, then it would just pop into existence. And I'd have to be safe. I'd have to move it a little bit away from the edge to be absolutely sure that it wasn't going to trigger the collision. And at some point, it would look visually bad. So I thought, most people when they fire from the center of their thing. They hide it underneath their turret or the thing that is firing, and then they do a little cheat, little hack. They go, oh yeah, shoot, that's hitting the thing that I don't want it to hit. I just ignore it for half a second. I'm good. This is the kind of thing that happens all the time. You think
Excellent.
When people see games that are like, wow, that looks so great, they must be great programmers, and they are. But great programmers, I'm not saying I am one, but programmers who are great, they know, sometimes you just got to cheat. You got to cheat a little bit.
It's an illusion. It's all an illusion, right? I mean, we've seen it over and over again.
Yeah. So it's all good and it works. Okay, so we got a bunch of other turrets, and it's way too much. One thing I do want people to see, let me just undo everything that I did to this file today. All the changes. Stop with the changes. Sorry. Okay, good. Hopefully that still works. Rocket turrets. So I just wanted to say that it's because I'm so proud of it. Where is it? So in order to do thrusting this forward, aiming at the player, including changing the aim as the player moves around, hopefully I don't get killed. To make it do cool stuff like that, 3 lines of code. So I very much encourage people to dig into the action library, which is now included with this game, and which will eventually come out as a plugin. But basically what happened there is I had an enter frame listener on the rocket, so every frame, ignore this part, which is just my safety code to make sure it hasn't been destroyed. Every frame, I tell the rocket to face this target, which is the player, and I set a rate. I say your maximum turning speed is 120 degrees per second, so you can't turn instantly. You got to take your time. And so it faces at a fixed rate, so you can change that, make it slower or faster, and that'll change the curve of the rocket. So example, if I made this 30, a real slow turn, I reloaded this. Now it doesn't turn very fast at all, right? You see how it can't seem to turn and hit me?
Mm-hmm.
Or I could set this to 360 degrees, load it, run it. Now it's going to woo. No problem keeping up with me. Or you could just take this off completely. And now, that's the same as saying immediately face me. Has no problem whatsoever facing me.
Yeah, but it runs now. It runs into the thing you're running around.
Yeah,
now.
so I like the smooth one. I chose 120 because I gave it a nice. It started to like follow me around platforms and stuff. That was pretty cool. So in one line of code, you handle all of that ugly, widgety, difficult calculation to do facing at a fixed rate or whatever rate you want to do, and then using the move physics sub library of actions, you say move forward, whatever forward is for you, and at a rate of whatever. So whatever speed I'm telling you to move at. So 2 lines of code does all the physics, all the calculations, and then finally another line of code here, which has nothing to do with the action library, which is the particles. And this thing comes with 6 different particle options. I encourage you to go into this code on line 128 and cycle through them and see what happens. For example, particle 1 is square trail. Particle 2 is circular trail. I won't show the others, but that's circular trail. After this one, I won't show you. And then the last one is a line. So it uses lines instead, which then are connected to each other, which I kind of like that one the best for this.
It's nice and smooth.
Yeah, it's smoother. And then 4, 5, 6 are square, circle, line again, but they are what I call rainbow. In other words, they're randomly colored. So just to make it look a little more jazzy. So, but all this code is nice visual effects in just a few lines of code. But again, I want to push the action library, which I've got coming up soon, because it's a big deal. I had it in my back storage for a long time, and I hadn't released it because I didn't have a good way to put it into the public in such a way that was maintainable for me. But as a plugin, is maintainable.
Yeah, well, it seems like it makes a lot of sense. You know, it's centralized, and now when you make changes, everybody gets it.
Yeah.
So,
all right, so I've gone a half an hour over. I do apologize for that.
So where does that leave us for next time? What do you want to try to talk about next time?
I think. Oh man.
Or do we just? Well, we can just talk about that later.
Yeah, I don't know. I've blown my brain cells out on this one.
Yeah, that's all right. Well, but it sounds like we still have more to cover. So let's just plan, I guess, to cover whatever's left on turrets.
Yeah, I mean, there's more on turrets. We could definitely take our time and slow down.
Yeah, today was an introduction to vector math and some of the concepts and things like that, and we went over the initial code. So I think, yeah, if we come back next time and maybe do like a short refresher, just to kind of.
Is that a hint to me? Short?
Well, no, that's not a hint to you. That's just
okay.
So everybody knows that we won't cover the same thing we covered today, but it would be good to kind of say, hey, if you didn't watch that other video, you can at least kind of get an idea of what's going on, and then maybe cover some of the pieces, because I know you had 3 or 4 different types of turrets there. So
yeah, we got 3 turrets so far, with a possibility of 2 more turret types.
Yeah, so let's do that. We'll look at that, and then whatever else comes up.
I'll take people on a slower play-by-play of the actual calculations so they understand what's going on next time.
Yeah.
I kind of just breezed over. Okay, take an angle, go to the right.
Yeah, exactly. And for me personally, I just sort of shortcutted that in my head. Said, okay, well, there's some vector math involved, and waved my hands around a little bit in my head instead of, okay.
The difficulty with vector math is it's like I keep finding myself wanting to talk about these things, but not being sure if people are 100% grounded in the terms I'm trying to use. Especially when I don't always do a good job of using them 100% correctly.
Yeah.
So.
Okay. Well, we're very good. Well, you guys know what to do. Download the code that Ed has provided. Compare it to what was discussed today. There's also 4 other episodes or shows that you can go check out at youtube.com/Corona Geek, where we've covered all the different aspects of this game. So go back and watch those as well to kind of pick out the pieces that are interesting to you. And until next week, have a great week and happy coding.
Yeah, and let us know if you want us to do an editor. People, please let us know.
Oh yeah, I really want to do an editor. I think that's a great idea.
Let us know.
Oh yeah, let us know. Tell Ed you want an editor.
Yeah, make it worth it.